wants us to find f divided by g of x. So we know the domain's not going to be all real numbers, right? So it's x minus 5 divided by x squared minus 1. You're done with that. You can't combine these. Can't reduce it any, right? I can factor the bottom and make it x plus 1, x minus 1, but it doesn't reduce with anything in the top, so it doesn't do me any good. Do not, absolutely do not, cross out your x's if they're attached to a number with a plus or minus sign behind them. They cannot reduce this. But the part of the work that we have to do on these problems is that we actually do have to find the domain. So what do we have to do to find the domain? Take the bottom and set it equal to 0. So the domain is everything except 1. You put it in that type of notation, or you can say from a negative infinity to negative 1, negative 1 to 1, and 1 to positive infinity. Any questions? Checkpoint 3 covers the same material, but it's just got a little bit more complicated functions. On checkpoint 3, it says we're going to let f of x be equal to the square root of x minus 3, and g of x is going to be equal to the square root of x plus 1. And they want us to find f plus g of x. So that's the square root of x minus 3 plus the square root of x plus 1. Right? Any like terms here that I can combine? Say no. Remember, for me to be able to combine square roots, and the stuff under the square root has to look exactly the same. Right? So, part B on here, and you're done, so you're done with that, listing them just like that. Part B wants the domain. Okay? So remember how to do the domain on square roots? Take the stuff underneath and say it's got to be greater than or equal to 0. So out of the first one, I have that x minus 3 has to be greater than or equal to 0. But it is true that x plus 1 has to be greater than or equal to 0 at the same time. I can't have it be either one or the other. So I guess really this makes this an or statement, because I can't let it be either one. Doesn't have to be an intersection. So solving this for x, I get x is greater than or equal to 3, and x is greater than or equal to negative 1. So I'm going to do this one in red. Okay, this says that I can have the stuff that's greater than 3. Right? Nah, I did to you. This is an and statement. I had it right to start with. That's that boy. And it also says that x has to be greater than negative 1. Now, what's my solution here? What's my domain? I know if I pick a number down here less than negative 1, it messes both of them up, and I know I can't have that, right? But what if I pick a number like 0? Would 0 work? Because if I put 0 into this one, it's still going to be negative, right? And they both have to be positive. So that's why the and statement means an intersection, George. So I have to have the place where I've got both lines drawn. I can't have just be one or the other. So my final solution here for my domain is that x has to be greater than or equal to 3. Can't be anything smaller than that, because then it's going to make either one or both of the others, of the function. One or both of the two terms of the function will have a negative argument underneath the radical. Everybody understand? You have to have the intersection for this to work. And you've got more than one thing that's a limiting agent. Nope. Going with this? The next objective is objective 3, and we're going to actually talk about these composite functions. This is a new operation. We've never had this operation before with numbers, but we can do composite functions. Composite functions are notated with a circle between them. F compose G. That's why I said, if you see F and G side by side, that means times. F compose G does not mean times. They use an open circle. That means F of G of X. So in other words, what I'm doing is I'm going to take a G of X function. I'm going to take a whole expression, and I'm going to replace X with that expression. Y'all have been doing this. When you did that F of X plus H, remember you took that expression X plus H and replaced X with it? So you've been doing this idea already. That's called the composition. So, this is the definition for composition. It means that we're going to take the G of X function and replace X and F with it. And we need to talk about the domain. This is in a blue box on page 226, if you want to look at it with me. The domain of this composite function is all of the x's, such that we have to have two conditions met. That x is in the domain of G. And that G of X, so in other words, the Y value that you get back from plugging in that X into G has to be in the domain of F. So I want you to think about this for a minute. When you evaluate these functions, this is what you do. You put the X that it asked you for into the G function. Then you take the answer to that problem, the Y value, and plug it into the Y. That's what that function is saying to you. That's what that notation means. Okay, so that means that I've got to check the domain of G and make sure that the result that I get back for G of X is in the domain of F. So let's look at checkpoint 4 and talk about actually forming these composite functions and what that looks like. So if they tell me that f of x is equal to 5x plus 6, and that g of x is equal to 2x squared plus 2x, no, minus x minus 1. So part A says I'm going to do f compose g of x. Now remember what that means. I'm going to take the f of x function. I want everybody watching. Let me give you a second to catch up with your writing. We good? All right, I'm going to take the f function. Everybody see the f function right here? I'm going to write it down, except where the x is, I'm just going to put a set of parentheses, because what this says is I'm going to take the g function and I'm going to put it into the f function. So where the x is in the f function, leave a hole. Now what you're going to do is you're going to stuff this g of x function in that hole. So I'm going to put the 2x squared minus x minus 1 in there. We are not multiplying them together. We are stuffing one inside the other. Okay? Now, when I simplify this, I am going to multiply, but I'm just going to distribute that 5. So I get 10x squared minus 5x minus 5 plus that 6. That wasn't multiplied by an x, so I don't do anything to it. I just write it down. Everybody see what I did? And then when I combine like terms, that's 10x squared minus 5x plus 1. You good? Now, you remember that thing called commutativity, which says that I can do 2 times 4 and 4 times 2 and get the same answer? So it doesn't matter which one comes first and which one comes second. We do have commutativity of multiplication. We have it of addition. But we do not have it of subtraction, right? Because 4 minus 2 is a different number than 2 minus 4. So I remember that commutativity idea applies for some operations and it doesn't for others. Well, it does not apply for compositions. Everybody hear what I just said? G compose F of X most of the time will not be the same number or the same answer. Because why? Because this says I'm going to take the G function, so I'm going to put the 2 down. I'm going to open a hole where the X was. I'm going to put the square on it. Everybody see what I'm doing? Minus, I got to open a hole for that X, minus 1. So everybody see that I just wrote the G function down, just everywhere there was an X, I left a hole in it. And I notate that with a set of parentheses. Now I'm going to take the F function because I'm going to put the F in the G. And I'm going to replace all of the holes or stuff the 5x plus 6 in all the holes. Now, of course, they want you to simplify this. They don't want you to leave it like this. So on the answer choices that are multiple choice questions, when you do that on the final or on the test, you got to know how to get from here to the final answer. So what would you do here first? 5x plus 6 times 5x plus 6 is exactly right. So you'd get 25x squared plus 60x plus 36. Right? Formula is I square the first term, first times the second times 2 because there are 2 of them, and the last one squared. If I'm subtracting off of parentheses, I need to do minus 5x and minus 6, minus the 1. I'm going to go ahead and distribute that minus sign through there, get rid of that parentheses. So I have to multiply through by this 2 now because I had to wait to do that until after I squared. So I've got 50x squared plus 120x plus 72 minus 5x minus 6 minus 1. And that would, when I combine like terms, that would give me 115x and minus 65. Is that what y'all got? No? Yes? Thank you.